Welcome to the other trig functions. We haven't talked much about anything else but sine and cosine. So now we're going to talk about the remaining 4 trig functions. Specifically, we're going to start with the tangent function, excuse me, and talk about inverse trig functions. Key points. We're going to talk about the tangent function, solving trigonometric equations graphically and algebraically, and we'll have an introduction to inverse trig functions, and we'll again talk about reference angles. Okay, first of all, the graph of the trig function. This one we've been doing a lot with sine and cosine, and if you'll notice, the tangent function looks much different. And if you recall, tangent of theta is y over x or sine over cosine. Because it is a fraction, whenever cosine of theta equals 0, I can't have 0 in the denominator, tangent becomes undefined. So if you recall from our table when we did, we had 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. We'll just talk about the first quadrant, or pi over 6, pi over 4, pi over 3, and pi over 2. If you recall, if I took the tangent of that, this one was radical 3 over 3, this was 1, this was radical 3, and then this was undefined. So when you graph something like this, and if you look at this, I'll start right here at the y-axis, you'll notice, okay, that at pi over 2 it's undefined because that's where cosine is 0. So your graph here starts from 0 and goes up to undefined, and then it starts back down here because tangent is negative in the second quadrant. So here's first quadrant, here's second quadrant, here's third quadrant, and here's fourth quadrant. So it has an asymptote when you do the graph. To me it looks like one of those chairs, and I have another one here at negative 3 pi over 2. Now, to write down a few things about the domain and range and asymptotes. Asymptotes are at pi over 2, 3 pi over 2, and they keep going. And you have at negative pi over 2 and negative 3 pi over 2, because that's where tangent is undefined. If you'll notice, when we talk about, before I had you stack and stack amplitude and frequency, period, and midline, if you'll notice with tangent, there is no amplitude because it goes forever to infinity. The frequency, you'll see actually 2 curves in there, but the period is only pi. If you'll notice, this one's different. There is no midline, if you will, because, I mean, you could say right here, but there really isn't a midline because there's no end or beginning. So this part is different. The period is pi, and there's no amplitude because that's what makes this distinctive. Now, to go back to some Pythagorean identities, and we talked about this earlier. So if I had a unit circle and I drew a right triangle here, and this has a radius of 1, if this was x and this was y, I could use the Pythagorean theorem and come up with x squared plus y squared equals 1. When we start talking about the angle theta, though, since we know that x is the cosine of theta and y is the sine theta, we can use this Pythagorean identity to find other information. So let's try this. For example, if I know the sine of theta is pi over 6 and theta is in quadrant 1, find the cosine and tangent. Well, first of all, quadrant 1 makes a big difference because that means my tangent and cosine are also positive. So you can actually use the Pythagorean identity, cosine squared of theta plus sine squared of theta equals 1. If I know that the sine of theta is 0.6, I can put it here and square it, and I can actually solve this equation. So I've got cosine squared of theta equals 1 minus 0.6 squared. So the cosine of theta equals 0.64, and if I take the square root of it, I find out that cosine of theta equals 0.8. Alright, so I now found cosine because of that identity. Now if I find tangent, tangent of theta is sine of theta over cosine of theta. Now all I have to do is say, okay, the sine of theta is 0.6, the cosine of theta is 0.8, and when I divide them I get 0.75. So the tangent of theta is 0.75. Okay? Now it says if sine of theta is 0.6 and theta is in quadrant 2, find cosine and tangent. Well, first of all, I know that cosine is negative in quadrant 2 and so is tangent. So I could use the same formulas because taking something squared is a plus or a minus. So I can say, okay, then the cosine of theta in that quadrant is going to be negative 0.8 and the tangent of theta in that quadrant is going to be negative 0.75. If I said the sine of theta is 0.6 and theta is in quadrant 3, find cosine and tangent. Now, cosine is negative and tangent is positive in the third quadrant, so this would be the cosine of theta would be a negative 0.8 and the tangent of theta would be a positive 0.75. Okay, so let's look more at other trig functions that we have. Okay, so we've spent a lot of time on sine and cosine and tangent. Now the other ones that we have to work with, the reciprocal functions, okay, is secant is 1 over cosine or 1 over x, cosecant is 1 over sine, and cotangent is 1 over tangent or x over y. You can also write cotangent as cosine of theta over sine of theta, which is because tangent is really, you can write as sine of theta over cosine of theta. And I have a sheet in your packet that has everything in there. So let's kind of look at the point on the unit circle, 0.6, negative 0.8. This I know when I graph is going to be in quadrant 4. Okay, so if I wanted to find all the 6 trig functions, the best thing I would do is let's change this into a fraction. So 6/10 is really, if you look at it, is 3/5. And negative 0.8 is negative 4/5. So this makes it easy because I know this is a cosine of theta and this is a sine of theta. We can actually find all the rest of the 6 trig functions. So I have sine of theta, which is negative 4/5, and we're in quadrant 4. Cosine of theta is 3/5. Tangent of theta, okay, tangent of theta is going to be sine over cosine, so it'd be negative 4/5 over 3/5, so that's negative 4/3. Cotangent of theta is going to be tangent theta switched, or flipped, excuse me, negative 3/4. Secant is the reciprocal of sine, so I'm going to flip that. Okay, cosine, so it's 5/3 and it's positive. I'm sorry about that. And then cosecant is sine flipped, or negative 5/4. So if you know a point, you can find the value of all the other trig functions. I would suggest that you do it in fractions. It makes it a little bit easier, but you can do it with decimals also. Alright, now if we had to find other Pythagorean identities, this is the main one right here, but you can find the other two by dividing each term by something different. So here, if I divided everything by cosine squared, this entire equation, I would come up with a new trig identity, which is 1 plus tangent squared theta equals secant squared theta. I don't expect you to memorize that, but it'll come in handy. The other way to do it is divide them all by sine squared theta, and when I do that, I come up with yet another identity of cotangent squared theta plus 1 equals cosecant squared theta. So you can use these identities to find other values. I'm going to show you a way that you can use these, and I'm going to show you more than one method to do this. So let's look at the first one. If tangent of theta is radical 7 over 3 and sine is negative, so tangent's positive and sine is negative, find cosine. Well, first of all, I have to figure out what quadrant this is. So I know tangent's positive in quadrant 1 and 3. I know sine is negative in quadrants 3 and 4, so must be, if it happens for both, we're talking this angle's in quadrant 3. Okay? Now there's two methods that you can find cosine. The first method is using an identity. So since they have tangent and sine, I do know they have one with, and they're looking for cosine. I know I can use this identity that we just found. 1 plus tangent squared theta equals secant squared theta. Now you're thinking, why are you using that? But secant is the inverse of cosine, so the reciprocal, excuse me. So I can actually find this, and when I'm done, flip it, and I'll have what cosine is. So I got 1 plus the tangent, and it's squared, equals secant squared theta. So when I square that, I get 1 plus 7 over 9 equals secant squared theta. So if I take the square root of both of these, because that will end up being 9 over 9, so 9 plus 7 is 16, so that's 8 over 3, 4 over 3, so I'll have the secant of theta can be plus or minus 4/3. Okay, well, if we're talking quadrant 3, I know cosine is negative, so the secant's also negative, so it must not be positive, it's negative. So if I want to know the cosine, I'm going to flip it. It's going to be negative 3/4. Alright? Now, you can find them that way, but I prefer this other method. So let me show you method 2. Method 2 is more visual for me. So I actually draw the part of my bow tie in quadrant 3 because that's where it is. And they told us that tangent's radical 7 over 3, and tangent, here's theta, is opposite over adjacent. The only thing you got to be careful of, you got to know where you are. And since I'm in that quadrant, both of those are negative. So then what you do is you do the Pythagorean theorem to find this, because I want to find cosine, and a cosine is adjacent over hypotenuse, and hypotenuses are never negative. So I say radical squared plus negative radical 7 squared plus negative 3 squared has to equal c squared. And when I do that, I have 7 plus 9 equals c squared. C squared is 16, so c is 4. So now I know this is 4. So the cosine of theta is adjacent over hypotenuse, or negative 3/4. I personally like this method better. It's more visual. You can use your identities to find that, but I think you have to do more manipulation. Alright, let's practice another one. If cosine of A is negative radical 2 over 2, so it's negative, so cosine is negative in quadrant 2 and 3. And if cotangent is positive, and cotangent is the same as tangent is positive, so that's positive in 1 and 3, again our angle is in quadrant 3. Let me show you both methods. So I'm going to do sine squared theta plus cosine squared theta equals 1. So I have sine squared theta equals negative radical 2 over 2 squared. Got my theta there, equals 1. This should be a plus sign right here. Sorry about that. Okay, so I have sine squared theta equals 1. And if I square that, it's 2 over 4, or 1 minus a half. So I have sine squared theta equals 1/2. Square root, so that's going to be 1 over radical 2, which we rationalize as radical 2 over 2, and that's what the sign is going to be. But if it's in quadrant 3, it's going to be plus or minus. It's going to be negative because you're in quadrant 3. Now, method 2, which I prefer, let's draw the picture. I'm in quadrant 3. Here's theta. They said that cosine is adjacent over hypotenuse. It's negative. This is the only thing that can be negative. So I do the Pythagorean theorem. So I do negative radical 2 squared plus, we'll call this, well, not x, we'll make it a y because that's really what it is, plus y squared equals 2 squared. So I have y squared equals 2, take the square root, so y equals 2. No, excuse me, take square root, it's negative radical 2. So if I was going to find sine of this, sine of theta is opposite over hypotenuse, so it's negative radical 2 over 2. So when you do this, it's really plus or minus, but since I know I'm in quadrant 3, I know y is negative, so that's why it's negative like that. Again, I think this method is a little bit easier. Alright, let's look at the relationships of the graphs of trig functions. And so first we'll define secant, cosecant, and cotangent functions as follows. And we talked about this. Secant is 1 over cosine, cosecant is 1 over sine, and cotangent is cosine over sine. Shown below are graphs of secant, cosecant, and cotangent, not necessarily in the order. Without using a calculator, match each graph with the correct formula. Well, the best way to do these is to actually graph a function that you know. So I'm going to graph this function here. And if you tell me what you think this is. This looks like a sine curve. If it looks like a sine curve, and I could keep continuing, come back over here, okay, and graph it like this. Notice at every max point is this hump, if you will. Well, basically, if this is a sine curve that I've graphed, the reciprocal function is the one that is going to come like this. So what's the reciprocal of sine? Oh, so this is the cosecant of theta. Okay? This one looks like tangent but the other way, so this must be cotangent of theta because it has a unique look to it. Secant is the only one left over, so if this is secant, then that means that this should be on the humps of cosine. So let's look at cosine starts high. And if you look at this, this is on the humps of this, and we'll repeat this over here. So this is cosecant. So it's really easy to tell which one it is just by looking to see if the sine or cosine. The cotangent is pretty clear, okay? Now let's practice with some inverse functions. And it's kind of like Jeopardy. They give you the angle. So when you see this cosine inverse or inverse cosine, in here is your answer already. Can you tell me what the angle was? So if I did inverse of cosine of 0, I say, okay, what angle is when cosine has a value of 0? And you could say 90 degrees or pi over 2. Another way you can see this written is arc cosine. Arc cosine and inverse cosine are the same thing. So if I said, okay, what angle gives you a value of 1? I can say that equals 0. Inverse cosine of negative 1 is over at pi or 180 degrees. Inverse sine of 1 is at pi over 2 at 90 degrees. Inverse sine of negative 1, so that's down here at negative 270, or excuse me, at 270, or 3 pi over 2. Inverse tangent of negative 1, well, if it's 1, that's pi over 4, but if it's negative, then it's in quadrant 2, so that's going to be 3 pi over 4. And the inverse, or the arctan of 1, is pi over 4. So if your calculator's in radians, it's going to give you a decimal back. If you're in degrees, it's going to give you the angle back. Okay? If I were to look at this one right here, inverse sine of negative 1/2, well, sine is negative in quadrant, let's look at it, 3 and 4. And if you were to think of 1/2, you would say, well, that's 30 degrees or pi over 6. So that's my reference angle is pi over 6. Well, what is pi over 6 in those two quadrants? So this could have two answers. Basically, what your calculator will tell you is probably 11 pi over 6, because that's the quadrant 4 angle, but it could also be 7 pi over 6 also, because that's in the other quadrant. Inverse arctan of negative 1, that's the one we've done before. So that could be actually 3 pi, so if it's -1, it could be in second quadrant, or 3 pi over 4, or it can be in quadrant 3. So you can put all these in your calculator if you want, but I look at my table, I know the sine of 30 is a half, so, or pi over 6. Inverse tangent of radical 3, well, that's pi over 3, or 60 degrees. Inverse cosine of 1/3, you'd have to put in your calculators. If you do this in degrees, it'd be 70.52, or roughly 71 degrees. Inverse sine of radical 2 over 2, let's go back to radians. It's 45 degrees, or pi over 4. So these two right here aren't on your table. Inverse tan of a half is 26.56 degrees, or roughly 27 degrees. So that's just a little practice with inverses, because we do use inverses to solve equations. I will do a quick little video in a little bit on how to solve equations.